In discussions of mechanics, we have talked about objects moving freely through the air. The only constraint on motion has been gravity pulling objects to the ground. In discussions on Newton's laws, we have talked about how objects behave when they have no constraints on them, Newton's first law. Our discussion of waves can be seen in many different ways. It can be seen as an object with two constraints, how far it moves positively and how far it moves negatively. It can also be seen as an object where we allow it to move through the source of the force and out again, or it can be seen as an object moving up and down and through time. Either way, waves can be treated as an object in their own right, even though, strictly speaking, they are not an object, but a consequence of other objects. A wave is an oscillation of particles of a medium. We are familiar with particles. They are small, hard dots that can move. Most of the objects in mechanics can be approximated to particles. There is a whole branch of physics studying the interaction of particles at minuscule scales. In this area of study, particles are merely the background to our area of study, the wave. Particles form a background called a medium. The medium is simply a background lattice of particles, equally spaced and with equal forces pulling each particle to each other particle. It is like the skin of a trampoline. The particles stay locked into this grid because if they move in a direction, the other particles in the grid pull them back into place. The grid can be a two-dimensional sheet or a three-dimensional block. The mathematics is the same for the grid to extend into 4, 5 or more dimensions. The key element is that if a particle is disturbed, the other particles will pull it back into place. A wave is established when a particle is knocked out of place. The surrounding particles pull this particle back to its original position, and in turn are pulled out of place by the moved particle. This movement moves the original displacement of a particle across the surface of our medium. It is this movement of a displacement across the surface that is the wave, not the individual particles moving, but the overall pattern that these movements make. For example, in a crowd of people in a stadium, one row of people may all move up at once. These are particles oscillating up and down. The motion of this movement up and down around the stadium in the form of a Mexican wave is the wave. Once we discuss waves in great detail, it will not be necessary to remember these aspects of waves. It is, however, helpful to remember that waves are moving disturbances in the medium, not an object in themselves. At least that is the classical interpretation of waves. When we study fields and light, it becomes more complicated.